Okay, I think we are live. Hi, good evening. Sorry, good afternoon, all of you. Welcome back to Cracku again. Yesterday we had covered time, speed, distance part 2. Today we will be covering progression and series, or you can say sequence and series. So, yeah, I hope that you would have gone through yesterday's session and you by far your preparation is also going well. The exam is in next month. I hope that you're preparing hard for the exam. In today's class, we'll cover progressions and series. Although I think some of the topics of this topic, this concept are already covered in class 11th and 12th. That is arithmetic progression and all, geometric progression also. But today we'll recap all of that and we'll do questions based on the specific formulas also, and we'll understand all the important types of questions that are asked in the exam. Okay. Yeah, so this is the schedule. Today we'll be covering progression series. After that, tomorrow we have linear equation. Tomorrow at the same time, because on the weekends our classes timing is 3 to 4:30. So tomorrow also we have 3 to 4:30. We'll be covering linear and equation. This is going to be an important topic again, because it's not going to be helpful just in algebra, but there are a lot of arithmetic and geometric questions where you need to make an equation and you will have to solve them. So the topic will be helpful there also. So I would suggest that you guys don't miss out any of this topic. From now on, all the topics are going to be very important, and considering we don't know the exact syllabus and exam pattern, you should not be missing out on any topic. So I would suggest that attend all the live sessions. And yeah, next, again, I think in yesterday's class also we discussed that why mocks are very important, because you need to sit for 2 hours, and then you have to be fully focused in those 2 hours. You have to attempt 60 questions. So, and considering you don't know the complete syllabus, so you should be better prepared for any surprises. For that, again, mocks are very important. If you are not taking mock, or you have not taken any single mock so far, I would highly suggest that you guys start taking mocks. On Cracku we have launched 5 mocks, and they are absolutely free. We have prepared the mocks thinking all the possible type of questions that can be asked, and we have tried to put all types of questions, attempt them, see what are your strengths, see what are your weaknesses, and all the mocks are again free. So you can this should be your first step. You should be appearing for the mocks without any hesitation. I would say that today is a Saturday, tomorrow is Sunday. You have both the weekends. At least appear for 2 mocks, 1 mock each day, and see where do you stand and what you need to prepare in order to actually do good in the exam. With that, we'll start today's class. Okay, yeah, one more thing. We have our WhatsApp group. So if you guys are thinking that, okay, where can you find all the important notifications, updates at one place, you can join Cracku's WhatsApp group. You can find the link for the same in the description. At Cracku, you will get all the important updates, all the important notifications. So you should not be worried about missing out on some important stuff. Just join the WhatsApp group, and we'll be putting all the important updates relevant for you. Okay, yeah. With that, we'll start. Now, I hope that you understand the concept of series or sequence. Basically, sequence is nothing but anything which is in a particular order. Here, let's say the order can be summation or subtraction, or can be multiplication or division between any 2 consecutive terms. Whenever the 2 consecutive terms are in a particular order, we call it a sequence. For example, we have this sequence, very basic stuff. You see that every term is increasing by 2. You can do reverse also. We can have, let's say, 10, 8, 6, 4. Again, this is also a sequence. So any number of series, any number of terms which are in particular order is called a sequence. Now there can be multiple types of sequences, but in our syllabus and considering the exam, what exam can test, we will be covering majorly 3 types of sequences which are actually relevant and which are generally asked in such competitive exams. The first one is arithmetic sequence. I hope that you have heard or studied this in your 10th, not 10th, but I think 11th or 12th in your mathematics, because since mathematics is compulsory for appearing, for being eligible for this course, so I hope that you would have studied arithmetic progression. Another one is geometric progression, and we have one more type of progression which is harmonic one. We will study the relation between all of them, but yeah, so sequence is nothing but the relation between any 2 consecutive terms. Okay, first, arithmetic progression. Now you know that arithmetic progression is nothing but when the difference between 2 terms in a particular sequence is constant. For example, let's say I write a sequence, and the sequence, let's say 8, 18, 28, 38 and so on. You observe that the difference between these 2 terms is 10. The same is the case here. The same is the case here. So whenever there are 2 consecutive in a sequence, the difference between 2 consecutive terms is fixed or constant. In that case, we understand that it is an arithmetic progression. Yeah. Okay. Now, how do you make a progression, or how do you define a journal term of a progression, specifically an arithmetic progression? We have a particular formula for this, but we will not directly follow the term. We will understand that how the formula is created. Let's say that first term for the starting term of the progression is, let's say 10, and the difference, or basically the difference between 2 terms is generally referred as common difference. So let's say the common difference is 5. So what will be the first term? First term will be, we have assumed that it to be 10. Next term, that is second term, will be A2. First term plus we are moving one step further and we are adding the common difference. So common difference will be 5. So second term will be 15. Third term, in the previous term we will be adding the common difference. So 15 plus 5, or we can write this as 10 plus 5. 10 plus 5 plus 5, which is nothing but 20. Now third, let's go for one more step. 15, that is previous term plus the common difference, 20 plus 5, or we can say 10 plus 5 plus 5 plus 5, that is equal to 25. Now if you notice the situation here, the first term is always fixed in all these sequences. It's just how many times the common difference is being added. So in the first term there is no common difference, because you cannot evaluate or compare the first term with anything. You are developing the series, so you will need another term. So in the second term you have added the common difference one time. In the third term you have added the common difference twice. In the fourth term you have added the common difference thrice, and then you will go on. In the fifth term you will add common difference 4 times, and this thing will remain constant. And with that only we create a formula, that is Tn, that is n is the number of term. Let's say you are finding term 6th. This is equal to first term, that is A. You always remember that in progressions, A is generally referred to as the first term. So A is the first term plus n minus 1. N is the the term you are finding. We are finding 6th term here. So n here will be 6 minus 1 into D. D again is a common difference. So T6 will be equal to A plus 6 minus 1 is 5D. So this is how we create a formula. You understand this? You just remember that A is the first term and we will be adding the common difference into the first term, one less than the term you are finding. Let's say for another term we are finding, let's say 48th term. So T48 will be equal to A plus 48 minus 1, that is 47D. This is how you can make a progression. You can make a you can find out the terms of a sequence. Let's put the same here also. Let's say you are trying to find the 4th term, that is A4. We already know it is 25. So A4 is nothing but A plus n minus 1, which is 4 minus 1, that into D, that is A plus 3D. We know that A is nothing but the first term, 10 plus 3 into D. D is nothing but 5, which is 15. This is equal to 25. The same our answer, that is 25. So here you just need two things. First is the first term, that is referred to as A, and then D. D is the common difference. Now it is not necessarily that D has to be positive. It can be negative also. A sequence can also be reducing. For example, we have, let's say the first term is 10, that is A is equal to 10, and D, that is common difference, is equal to minus 2. So first term in that case will be 10. Second term in that case will be 10 minus 2, which is 8. Third term will be 10 minus 2 and minus 2. We are reducing twice. Or you understand that 10 plus minus 2, because this is our common difference, plus minus 2. This will be equal to 10 minus 2 and minus 2, and this will be equal to 6. So you see that in here, because our common difference is negative, our sequence is reducing, or it kind of towards the left side of the numbers of the number line. Yeah, so this is one thing. This is the important formula we have, that is you can find out any term if you know the first term and the common difference. If you notice here, it is just to refer that what is the first term. First term is 3 only, and here our sequence is 3 and 6 and 9 and 12. You can clearly observe what is the common difference. If you are not able to understand a common difference, just subtract any two consecutive terms, or basically you can find out common difference with A n plus 1 minus A n. That is basically the next term minus previous term. That is how you will understand that by how much the next term is increasing or decreasing. Here the second term, let's say this is A2, n is equal to 1 minus A1, that is 6 minus 3 is equal to 9, is equal to 3. So we know that the common difference here is 3. With that, D is 3, A is 3, you can find out any number of terms. Let's do a question. Let's say the first term of an arithmetic progression is 100, and the common difference here is, let's say, minus 15. Let's find out the 15th term. Okay, putting into the formula, we have A, that is the first term, 100, plus n n is the term which we are finding. We are finding 15th term. So n will be 15 minus 1 into d. D is negative, so minus 15 is equal to 100 plus 14 into minus 15. That is 100. This will be negative. 15 into 4. 15, 150, 210 to 180. And if you subtract, this will be nothing but 210, sorry. And this will be nothing but minus 110. So you because the common difference here was negative, it was reducing. Hence 15th term in that case is minus 110. So this is how you can calculate We'll move on to the next slide. So in this slide, we have just covered what is the nth term. Okay. Now we have, if I am given the sequence in an arithmetic progression and I want to find out the sum of the sequence. Let's say the sequence is 10, 15, 20. And this is till up to, let's say this sequence is till 20 terms. Now I want to find out the sum of all the terms in this sequence. For that we have two specific formulas, or second one is nothing but slight expansion of the first formula only. That is Sn. Sn is the term which you are trying to find. Let's put it here. Let's put the our direct series only. This is our arithmetic progression. Here we know that A, the first term, is nothing but 10 only. In that case, our D, common difference, is nothing but second term minus first term. That is 15 minus 10. That is equal to 5. And we want to find out the sum of 20 terms. So n will be equal to 20. You have all the things. If you put it, S20 is nothing but n divided by 2. 20 divided by 2 is 10. Twice of A, that is 20, plus n minus 1. We are finding 20 terms. 20 minus 1, 19, into D is the common difference, 5. Or we have S20 is equal to 10. This will be 20 plus 19 into 5, 95, and 20, 10 into this will be 115 or 1150. This is how this will be the sum of all the series in this sequence. Now how did we find out the second term, second formula? It is nothing but, you would be assuming what is L. L is nothing but the last term of the sequence. If you know the last term of the sequence, you just put first term and last term into n by 2. If you don't know, you can follow the first formula only. But how did we came to the second formula from the first one? It is nothing but, we have Sn is equal to n divided by 2, 2a plus n minus 1 into D. Now, can we write 2a as a plus n minus 1 into D? And if you notice that this is nothing but our nth term only, or we can say the last term. If you put the values, you will get the last term. So we can replace this whole part. This is exactly equal to, if you notice, our main equation. So if you can replace this with our last term, and that is again equal to our main formula. You can find out using the same, so there are only these two formulas for finding the sum of an arithmetic progression if you are given the first term and the common difference, and obviously how many numbers are there or how many terms are there in the sequence. Let's do one more question here. Let's try to find out the sum of these sum of the terms in this sequence. There are 10 terms, or the terms can be many, but we need to find out the sum of first 10 terms in this sequence. We'll try both formulas. In this case, we don't know the last term, but we can calculate the last term and then we'll put the value. Let's do it with the first one. So we have n is equal to first 10. We are finding the sum of first 10 terms. A is equal to 5, the first term, and common difference. Common difference is nothing but second term minus the first term. 8 minus 5, that is equal to 3. If you put the value here, so we have S10 n divided by 2, that is 10 divided by 2 twice of A is 5 plus n minus 1. N here is 10, 10 minus 1 is 9 into D. D is 3. Or this is equal to, if we cancel, this is 5. 5 into 2, 10 plus 9 into 3, 27. Or 5 into 37. If you calculate, this will be 5. This will be 5 and 1, 8. So the sum of first 10 terms of this sequence is equal to 185. Let's cross confirm. Yeah. Let's do it with second formula. Now in that case, we are required the last term. We don't know the last term. Our last term of this sequence is nothing but the last term of the sequence for which we are finding the sum. We are finding the sum of first 10 sequences, or sorry, first 10 terms of the sequence. So we need to know the 10th term, or basically we want to know A10. A10 we just did that, it is nothing but A plus n minus 1 into D. Putting a value of n here, it will be A plus 10 minus 1 into D, that is A plus 9D. A is nothing but the first term, which is 5 plus 9 into D is 3. We have just calculated, so this will be 5 plus 9 into 3, 27 plus 5, 32. If you put the value here, S10 is nothing but 10 divided by 2 into A, that is 5 plus 32, or this will be 5 into 37, again the same value, which is 185. So whenever you are asked the sum of any number of terms, you should know only three things: the number of terms for which you need to find the sum, the first term, and the common difference. Let's move on now. Okay. In the first part, we covered what is arithmetic progression and how to find out the terms, and then how to calculate the sum. Now in the second case, we have geometric progression. Now here again, the term can increase or decrease, but in arithmetic progression, the term was increasing or decreasing with either addition or subtraction. But in geometric progression, the terms are increased or decreased by either multiplication or division with a particular number, and that particular number we refer as common ratio. For example, let's take it very simple sequence. Okay, let's say the first term of a geometric progression is 2, and the common ratio is, let's say, is 3. So now we have assumed first term is 2, so A1 is equal to 2 and common ratio is R, that is equal to 3. So second case will be, now the second case will not be sum of the common ratio, it will be multiple. So second term will be 2 into 3, that is equal to 6. Third term again we will multiply the common ratio, that is 6 into 3, 18. In the fourth term again we will multiply with the common ratio, that is 18 into 3. So this way basically in arithmetic progression we were adding or subtracting the common difference. In geometric progression we are either multiplying or dividing the first term with the common ratio, or basically consecutive terms. So here if you notice, all the numbers are into 3 of the previous term, and this could also be possible for a division. For example, let's say our first term is 1000, that is equal to A1. Now our common ratio is R is nothing but 1/5. Now if you think that 1/5 is nothing but in a fraction value, but again we'll multiply the same. A2 will be 1000 into the multiplication of this term, 1/5. If you notice, you might think that the value will be 200. Now you think that the value is actually divided, but it is nothing but you have multiplied it with a proper function. So whenever you are multiplying any previous term with a proper fraction, the value get divided. So here we have 200. Now A3 will again be second term into the common ratio, which is 1/5, and this will be again 40. A4 will be last term into common ratio, this will be 8. So if you notice, division here means you are multiplying the previous term with the proper fraction. So this way in geometric progression we are so next term will be multiplication with a fixed or constant common ratio. Let's read a sequence where each term is obtained by multiplying the previous term by a constant ratio. This constant ratio is referred as R. So as we just discussed, if first term is A and the common ratio is R, nth term will be A into R, that is common ratio, raised to n minus 1. For example, here if you erase this part is nothing but 1000 into 1/5. This part is nothing but 1000 into 1/5. You will get this value. Sorry. Yeah. So this part is this value into again 1/5. Here this is nothing but 1000 into 1/5 into 1/5. This value is equal to this. Again you are multiplying with 1/5. So if you notice, first term is equal to, we have first term is equal to first term is equal to 1000, second term is equal to 1000 into 1/5, third term is equal to 1000 into 1/5 square, fourth term A4 is equal to 1000 into 1/5 raised to 3, and this is for every subsequent term you are multiplying with common ratio. So that is how we arrive at the formula, that is whatever number you are finding into the first term into the common ratio is raised n minus 1 times. Why n minus 1 times? Because for let's say for the fourth term you are multiplying with common ratio only 3 times. First time to arrive at the second term, second time to arrive at the third term, and fourth time to arrive at the actual fourth term. So this way you arrive at this formula, that is Tn is equal to A into R raised to n minus 1. Let's do it this example. This is like, if you notice, how can you find out the common ratio? In the previous arithmetic progression, you can find out the common ratio, common difference by subtracting first term from the second term. Now in this case, you can arrive at the common difference by dividing the second term and first term. So common ratio here will be second term divided by third term. This is also possible here also, 8 divided by 2, 16 divided by 8. In all these cases, the common ratio is equal to 2 because the common ratio is always constant. So if you have to find out, let's say, fifth term of this series, so you need to find T5, term 5, that is equal to A. A is 2 into R, that is the common ratio 2, raised to n minus 1. We are finding the fifth term, so n is equal to 5. 5 minus 1 is 4. If you notice, this is 2 into 2 raised to 4, 32, and this will be 16, and this will be equal to 32. So fifth term of this sequence will be 32. This was a very small example. In your calculation, you might notice quite a heavy common ratio or abstract common ratios. In that case, the calculation can be complex, but all in all, you have to remember just the formula A into R is to n minus 1, and you can arrive at the any nth term. Let's move on. Now, similarly, like we can find out the sum of the terms of some of the terms in a particular sequence. We can also find out the sum of the terms in a geometric progression, and for that also we have a straightforward formula. So if your common ratio is not equal to 1, why specifically not equal to 1? Because if the common ratio is 1, it means you are multiplying every term with 1 only, and if you are multiplying any term with 1 only, you are getting the same value. So it will not actually make a proper sequence. So we have to consider that R is not equal to 1. In that case, sum is equal to sum of nth terms is equal to A into R raised to n minus 1 divided by R minus 1. This is a very simple formula. You can easily memorize this. But within that, there is a unique type of sequence where R is less than 1, or basically modulus of R is less than 1. What do I mean by modulus of R? Modulus of R basically nothing but less than 1 or greater than minus 1. Why is this a unique type of series? Let's assume any number between this range. Let's say 1 by 2. And let's say any sequence, and the first term let's say is 200. So first term is 200, A1 is equal to 200. A2 will be 200 into common ratio 1 by 2, that is 100. A3 is equal to 100 into 1 by 2, 50. A4, 50 into 1 by 2, 25. If you notice, whenever there is a common ratio between 1 and minus 1, or basically a proper fraction where numerator is less than the denominator, in that case, every subsequent term will be smaller than the previous term. 100 is smaller than 200, 50 is smaller than 100, because it is not making any, because if you notice that this value is nothing but 0.5, and if you multiply any decimal value, your answer will be shorter one. In that case, this sequence will be, for every term, the sequence will be half of the previous term. And at some point, the value will be so small that it would be negligible. And for that, we can't add them up into our addition, because it does not make any logical sense to add negligible value to our sum. That's why we have a special formula if our common ratio is between this range, and that is sum of infinity. Why we consider infinity? Because this term will never end. It will keep on reducing by half in this case, and at some point the value will become so negligible that it won't matter, and it will still continue getting half. So that's why it will never stop. That's why we consider this type of series as infinity. So sum till infinity is nothing but a divided by 1 minus r. A is again the first term, r is a common ratio. So this way we have two types of sequences. For sum, if our common ratio is not equal to 1 and not within this range, we'll use simply this formula, and our common ratio is between this range, we'll simply use this formula. These are pretty straightforward. We can do one example of both. Let's say here the sequence is 3 into, let's take a smaller one to calculate. It will be easier to calculate, or basically simply to calculate. Let's say our number is starting with 10 and it is multiplying with 2, or basically the first term is equal to 10 and common ratio is equal to 2, and we need to find the sum of, let's say 10 terms of this series, or 20. Putting it into the into the formula, we have S20. This is equal to A. A is 10 into, let's do this, 21. So 10 into, that is A into r raised to 1. The common ratio is r, that is 2 raised to n, that is 21 minus 1, divided by r minus 1, that is 2 minus 1. So 10 into 2 raised to 21 minus 1. This will simpler be our sum of the first 21 series of this equation. Of this sum of the first 21 terms of this sequence. If you calculate this, this will be a bigger value, minus 1 into 10. Because if you notice, this value will become very larger. If you are multiplying every term with 2, it means you are doubling them up. Let's say 20, 10, 20, 40, 80, 160, 320, and after one point the value will become very large, and that is how also the concept of compounding works. At one point they are increasing with, they become very high numbers because they are keep on multiplying. And let's do one more example for this type of series where our common ratio is between 1 minus 1 to 1. We have an example here. This is an infinite series, obviously, because whenever the ratio is this, the series will be an infinite only until unless it is specifically mentioned. So we have the first term, second term. How do you find out the common ratio? You divide the first term and second term. So second term is 1 by 2 divided by 1, and that is equal to 1 by 2 only. So common ratio is equal to 1 by 2 and first term is equal to 1 only. Putting into the equation, we have s till infinity is equal to first term divided by 1 minus 1 by 2. This is equal to 1 minus, this will be 1 by 2. The denominator of the denominator will go in the numerator. So this will be 2 by 1, or this will be equal to 2 only. So the sum till infinity of this series will be equal to 2 only. Yeah, so this was the second part of the geometric progression, that is sum of the series. Let's move on to the next slide. Okay, this is the third type of progression, and it is pretty interesting and simple also. It's just reciprocal of an arithmetic progression. So harmonic sequence is nothing but if there is a series in an arithmetic progression, and if you does reciprocal of it, that will become an harmonic progression. For example, there is a sequence, let's say 3, 6, 9, 12. This is in AP. If you do the reciprocal of this, 1 by 3, 1 by 6, 1 by 9, 1 by 12. Now this will become a harmonic progression. Very simple. So again, a sequence whose reciprocals form an arithmetic progression. If A1, A2, A3 are in harmonic progression, then 1 by A2, 1 by A3, 1 by A2, 1 by A3 will be in arithmetic progression, or vice versa. How do you find the nth term? If you know how to calculate the nth term of an arithmetic progression, you do the same. You just put it into the reciprocal. Tn, if we know that this is to calculate the nth term of a arithmetic progression. If you put this into 1, if you put it into denominator, then it will become a nth term for a harmonic progression. That is all there in harmonic progression. There is nothing much to understand. It's just this, that they are inversely proportional. I would not surely say that they are inversely proportional, but if you put the 1 into reciprocal, then harmonic progression will become an arithmetic progression, and vice versa. Okay, these are the two important things that I think you should know. That is, first, how do you calculate the mean of, if there is n number of series, n number of terms in a arithmetic progression. Let's say the terms are A1, A2, A3 till AN. Then how do you calculate the mean of this series, mean of the sequence? So for that, if n is in an odd number, or there are odd number of terms, then the middle number will be equal to the mean of this number, of this sequence. Let's understand this with an example. Let's take a smaller example. Let's say the series is 1, 2, 3, 4 and 5 only. If the number of terms are odd, we know that there are 5 terms only, so number of terms are odd. The mean of this sequence will be equal to the middle term, that is equal to 3. How do you calculate? We know that mean is nothing but sum of the terms divided by number of terms. The sum will be 3 and 3, 6 and 10 and 15 divided by 5, that is equal to 3, which is the middle term. So if the number of terms are odd, then the mean is equal to the middlemost term. If the number of terms are even, then the mean will be equal to the mean of the middlemost two terms. Let's say 1, 2, 3, 4, 5, 6. In this case, the number of terms are even. So mean will be the mean of the middlemost two terms. Middlemost two terms are 3 and 4. The mean of this is 3 plus 4 divided by 2, 3.5. So the mean of this sequence will be equal to 3.5. Yeah. So this is about the mean, or you can also say that if 3 terms are there in AP, that is A, B and C. There are odd number of terms, so mean will be equal to B. So B will be equal to A plus C divided by 2. So this is another form you can write. Or if you know that, if let's say we have 3 terms, A, B and C. So first term can be written as A. Second term can be written as A plus D. Third term can be written as A plus 2D. So we can write, if we put the value here, we have A plus D is equal to first term and last term. That is A plus 2D divided by 2. This is nothing but 2A plus 2D divided by 2. And this will be equal to A plus D only, same value. So you can memorize this also. This is also a concept you can use or apply to find out the middlemost term. If you want to find out if you have the first term and last term, or if you know the middlemost term, you can find either of them, the first or the last. Similarly, we have the concept, one more concept here in geometric progression. What is in geometric progression? We know that common ratio is constant always in geometric progression. That is, if we divide the second term with first term, that should also be equal to if we divide third term with second term. Let's say we have the geometric progression 2, 4, 8. Let's take another one, 3, 12, 48, and so on. How do you calculate the common ratio? You divide the second term with the first term. So common ratio will be equal to 12 divided by 3. That is equal to 4. And in another case, common ratio will also be if I divide third term with second term, because this term is arrived after multiplying this term with common ratio. So if you divide this with this, you will arrive at the common ratio. That is also 4. So when common ratio is same, we can say, if let's say we have the three terms A, B and C. So we can say common ratio will be equal to B divided by A, and common ratio will also be equal to C divided by B. Now if you notice only these terms, these two ratios will be equal. Now if you cross multiply, you will get B square is equal to A into C, or the square of the middlemost term will be equal to the product of the first and the third term, or first and the last term if you are given n number of terms. The product of the middlemost term will be equal to first term and the last term. This can be applied when you are given any odd number of terms. So yeah, these were the two concepts, two minute or I would say observations that you can apply if you want to find out mean or the middlemost term quickly in arithmetic and geometric progression. Let's see what we have next. Okay, these basically you are usually required to find out some specific types of sequences, and you are directly asked what is the sum of those sequences up to a particular number. So we already know there is a fixed formula for known series. Let's say the first series is natural numbers from 1 till any number we can consider. So if we want to find out the sum of the first n natural numbers, that is sum of 1, 2, 3 and 4 till n, then you can simply use this formula, that is n into n plus 1 divided by 2. For example, if we want to find out the sum of first 5 natural numbers, that is 1, 2, 3, 4, 5. So n is equal to 5. If we apply n is equal to 5 here, I will get 5 into 5 plus 1, 6 divided by 2, and this will be equal to 15. And if you add this up, 3 and 3, 6 plus 4, 10, 15. So this is also 15. But this was a very small number. If I ask you to find out the sum of first 100 natural numbers, you cannot manually add them up. For that, simply put n is equal to 100 and you can get your answer. Similarly, there is another series which is quite famous. If I want to find out first n odd numbers only, let's say, or if I want to find out sum of first 5 odd numbers, that is 1, 3, 5, 7, 9. If I want to find out the sum, so we want to find out the sum of first 5 natural numbers, put 5 in here only and you will get your answer. So sum of first 5 natural numbers is n square, that is 5 square, which is equal to 25. Let's check. 1 and 3, 4 plus 9, 9 and 18 and 25. So again, you don't need to calculate the sum manually. Just put the value of n into the equation and you can arrive at your answer. Similarly, the not opposite but complementary series will be an even number of series. We know that we have calculated the first n natural numbers, then first n odd numbers. Now another series is if I want to find out the sum of first n even numbers, again you put the value of n here, that is n into n plus 1, or you can say n square plus n. You will get the answer. For example, let's say I want to find out the sum of first 5 even numbers, that is 2, 4, 6, 8 and 10. So I want to find out the sum of first 5 even numbers. Putting the value of n is equal to 5. In the equation we have n square, that is 5 square 25, plus n, that is 5. This is equal to 30. If you calculate, this will be 6, 12, 20 and 30 only. So for if you are asked directly the sum of first n natural numbers, first n odd numbers, first n even numbers, you remember these formulas, these 3 ones, and you can arrive at your answer. Other than that, there are 2 more types of series which are actually commonly asked. That is the sum of the squares of first n natural numbers. Let's say we have 1 square plus 2 square, 3 square up till n square, and I want to find the sum. This is not sum of first n natural numbers. This is sum of first n natural numbers square. So for that also you have a specific formula. You might think that these formulas are being very overwhelmed, but if once you understand the concept and you start applying, they will become very frequent and you will easily remember them. I'm sure that these formulas will be applicable in multiple different kinds of question also, for you to do the calculations faster. So just understand the concept, start applying, and you will remember the formulas very quickly. Okay, so let's say if I want to find out the sum of first 5 n natural numbers square, that is 1 square plus 2 square plus 3 square plus 4 square plus 5 square. So n is equal to 5. We have 1, 4, 9, 16, 25. This is 10, 35 and 45. No, 55. 10, 20, 30, 55. Let's put it here. N is equal to 5. So 5 into n plus 1, 6 into 2n. 5 into 2, 10 plus 1, 11 divided by 6. 6 and 6 will cancel out. This will be 55, which is equal to our answer. So if you want to calculate first n natural number square, just put the value of n into the formula. Another, which is slightly another version of this only, if you want to find out the cubes of the first n natural numbers, you put the value of n here and you will get your answer. Let's say the value of first 3 natural numbers. This is equal to 1, this is equal to 8, this is equal to 27. If you add this, this will be 36. So you need to calculate the sum of first 3 n natural numbers, n natural numbers cubes. So 3 into 3 plus 1, 4 divided by 2, and this square. If you cancel, this will be 2. So 3 into 2, 6 square. That is equal to 36, which is our actual sum. So these were the major concepts in arithmetic and progression. First we covered arithmetic progression. We covered how to calculate the Tn terms, and then we calculated how to calculate the sum of the terms. Then we covered geometric progression. Again we covered how to calculate the terms or how to find out the specific term, and then we calculated sum of the terms and sum of a geometric progression which is having common ratio in a proper fraction. And then we have covered harmonic progression, and lastly we have covered spatial series. These are majorly 4 important topics that are there in the sequence and series concept. Now we'll do some questions based on these concepts only. Okay, this is the first question. We have, you have 2 minutes for the question. I think this is an easy question based on sequence. It is not necessarily that sequence has to be one of arithmetic progression, geometric progression, or a harmonic progression only. It can be any other also. If it is following a particular order, it will be called a sequence. So try to see what order is being followed here, then we'll check the answer. Okay. Before we start, Garvit was asking, can we at least pass the exam if we start now? Okay, Garvit, basically the exam is not something that you have to learn something new. It is going to test your aptitude and your quant skills. So if you have gone through this mentioned schedule, first it has English, which I assume is going to be around your basic comprehension and your grammar understanding of English only. It is not going to be something very complex. Another one is your quants and DI. So quants is going to be on the same side. It is going to be on aptitude level. DI is going to be based on your understanding and comprehension of data, and if you are able to properly interpret or not. And then we will have some sort of LR, that is logical reasoning. So again, in logical reasoning, I think it is not going to be very much complex. It is again going to be if you are able to think properly and think logically and solve a complex, not even complete complex, but solve a logical caselet. The caselet can be based on arrangements, or it can be based on some sort of scheduling and something like that. If you are able to deduce the queues and make the final table or final arrangement which is satisfying all the queues, then I think that is all. So it is not going to be something very much new. If you just practice a little bit, follow the schedule, practice on the quant side and logical reasoning side, and work on your slide comprehension, it is not going to be very hard. Again, I would say that appear for the mocks. That will also tell you where do you stand. and that will also tell you in what section you need to work more. It can be that you are very good at quants, but you need to work more on your English side or logical reasoning side, or it can be other way. So if you appear for the mock, then you will realize, okay, where do you stand, and then you can better prepare yourself for that section. Okay, we'll move on to the questions. Okay, so we have given that the first term of a sequence is 8. So A1 is equal to 8. Now we are given that every next term is in this order. So let's say if I want to find out A2, that is second term. Now I can write A2 as A1 plus 1. So n in this case is equal to 1. If you compare with the equation, n will be 1, and this is equal to 2 minus 4 divided by an, and n here is 1. That is equal to 2 minus 4 divided by a1. a1 is equal to 8. This will be equal to 1 by 2, and this equation will be equal to 3 by 2. So from first term we have calculated the second term. Now let's find out the next term. Let's say we'll calculate A3. If we write in this form, again we can write A3 as A2 plus 1. So n here is 2. That is equal to 2 minus 4 divided by an, and n here is 2. That is, we have to divide 4 with A2. So 2 minus 4 divided by A2 is 3 by 2. 3, and denominator goes in numerator. This will be equal to 2 minus 8 divided by 3. If you calculate, this will be 6 minus 8 divided by 3, or this will be minus 2 by 3. So we have got first term, we have got second term, we have got third term. Usually in this kind of questions, you will easily identify a pattern. I would say that try to find some more terms if you have still not figured out a pattern. So far we have 8, we have 3 by 2, we have minus 2 by 3. We have not figured out any specific pattern, so we'll move on and we'll try to find some more. So we have A4 is equal to A3 plus 1. So n here will be 3, and that is equal to 2 minus 4 divided by A3. This is equal to 2 minus 4 divided by A3 is minus 2 by 3. So this is minus 2. Again denominator, if there is a denominator in the denominator, it goes to the numerator. So this will be 3. 2 minus and minus will be plus. This will be 2 and 2 cancel. This will be 6. And this will be equal to 8. So we have arrived at the first term. If we solve for the next term, then we'll get the next term, that is 3 by 2. If we solve for A6, then we'll get again minus 2 by 3. And this way the whole sequence will work. The first term is 8, second term is 3 by 2, third term is minus 3 by 2, minus 2 by 3. And again in every 3 cycles these terms will repeat. So we can notice that we need to find A17. A17 will be equal to 3 terms prior, that is A14, and A14 will be equal to 3 terms earlier, that will be equal to A11. A11 will be equal to A8, and A8 will be equal to A5. A5 will be equal to A2, because every third term is equal. First term is equal to fourth term, second term is equal to fifth term, third term is equal to sixth term, and this 3 terms of cycle will keep on repeating. So if we want to calculate A7, that will be equal to A2, and we know the value of A2 is 3 by 2. So answer of this question is option B, 3 by 2. So in all such kind of questions, try to find the pattern. Once you identify the pattern, just calculate what cyclicity is there, at what cycles the terms are repeating, and then see in the same relation where your actual term you are trying to find will be equal to what value. Okay, we'll move on to the next question. Okay. Okay, this was again based on sequence only. We are given some conditions and we need to find particular relation. Here we are given for a sequence, we have first term, we have second term, we are given the relation, and then we are asked the difference of the seventh term and sixth term of the sequence. So we'll move on, we'll find out the seventh term and sixth term individually, and then we can find the difference. So we have A1 is equal to 2. We have A2 is equal to 5. Now A3, here n is equal to 3. That is equal to an minus 1. N is 3. 3 minus 1 is 2. That is A2 plus an minus 2. N is 3. So 3 minus 2 will be 1. A1 plus 3 raised to n minus 2. N is 3. So 3 raised to 3 minus 2. That is equal to A2 is 5. A1 is 2 plus 3 raised to 3 minus 1. 3 minus 2 is 3 raised to 1. That is 3 only. And this is equal to 10. So we have got A3 is equal to 10. Okay. Let's find out A4. A4 is nothing but n minus 1. N here is 4. So 4 minus 1 will be 3. So that is A3 plus n minus 2. N is 4. So 4 minus 2. That is A2 plus 3 raised to n minus 2. N here is 4 minus 2. That is A3 is 10. A2 is 5 plus 3 raised to 4 minus 2 is 2, and 3 raised to 2 is 3 square, that is 9. So this will be equal to 14 and 10, 24. Okay. Let's calculate A5. A5 is a 5 minus 1, that is 4, plus a 5 minus 2, that is 3, a3, that is based on these, plus a raised to n minus 2, n here is 5, so 3 raised to n minus 2, that is 5 minus 2, that is 3. a4 is 24 plus a3 is 10 plus 3 raised to 3 is 27, that is equal to 24 plus 10, 34 plus 27, and this will be equal to 61. Yeah, we need to calculate a7 and a6. We'll calculate a6 now. a6 is equal to a5 plus a4 plus 3 raised to n minus 2. N here is 6, so 6 minus 2 is 4. a5 is 61. a4 is 24 plus 3 raised to 4 is 81. That is 6 and 16. Lastly, we need to find a7, that is a6 plus a5 plus a raised to 7 minus 2, because n is 7, that is 3 raised to 7 minus 2 is 5. This is equal to a6 166, a5 61, 3 raised to 5 is 243. If you add them up, this will be 24, 16, 61. Let's calculate. 470. We need to find a7 minus a6, that is 470 minus 116. If you calculate, this will be 4 and 3, 304. So the answer has to be option number C. Now in this case, if you notice, this was very straightforward. You are given the equation, put the value, arrive at the answer, you calculate whatever difference we are asked. We are asked the difference, so calculate the difference. It was pretty straightforward question. We'll move on to the next question now. Yeah. This is also a very common kind of question asked, and we'll have a very unique approach to solve such kind of questions. Let's try out and see if you are able to solve this one. Okay. So basically here we are given two series and we are asked that how many common terms are there in these two series. whenever you find such kind of question, I would suggest that you always define nth term of a series. And how can you arrive at the nth term of a particular series? For example, let's say for the first series we have 9, 12, 15, 18. We know that a here is 9 and common difference is 15, 12 minus 9, that is 3. So how can you write the nth term? That is an. We know that an is equal to a plus n minus 1 into d. If we put the values here, we have a, that is 9, plus n we don't know, we are calculating for each term, into d. D is equal to 3. This is equal to 9 plus 3n minus 3, or basically 6 plus 3n, that is equal to an. And this is the general form for calculating the nth term of a particular equation. How? If you want to find out the fifth term, just put the value of n is equal to 5 and you will arrive at the fifth term. So this is the nth term for the first series. Similarly, we can find out the same nth term for the second series. In second series, we have common difference. We have the first term is 8 and the common difference is 13 minus 8. Second term minus first term is equal to 5. Putting the values, we have, let's say for this we assume that mth term, that is equal to a here is 8 plus m minus 1 into d is equal to 5. So 8 plus 5m minus 5, or this will be 3 plus 5m. This is the mth term for the second series. Now why I have taken m here and here? Basically it is not necessarily that if nth term of this equation and this equation will be same. The terms could be same but at different positions. So now we are asked that how many terms which are common here, which are part of this also and this also. Now for a particular term to be part of this kind of equation, the first kind of equation and second also, both have to be of this form only. So if we equate these two, that is 6 plus 3n, this should be of the same form, that is 3 plus 5m also, because the terms are equal, so both should be in such sequence or in such form. So if we equate, we have plus 3 here, it come here, it is minus 3, so 6 minus 3 is 3, 3n is equal to 5m, or we can write this as 3 plus 3n divided by 5 is equal to m. Now just calculate for what values of n and m it satisfies. If we put n is equal to 1, so 1 into 3, 3 plus 3, 6. 6 cannot be divided by 5, so 1 is not possible. Let's try 2. If we put n is equal to 2, that is 3 into 2, 6. 6 plus 3 is equal to 9. 9 divided by 5, not possible. Let's try 3. If we put 3 here, so 3 and 3 is 9. 9 plus 3 is 12. 12 cannot be divided by 5, so again not possible. Let's try 4. If we put 4 here, so 4 into 3, 12 plus 3, 15. Now 15 is divisible by 5. If we divide 15 by 5, m will be equal to 3. So the first term where both of these are equal, when n is equal to 3 and m is equal to, n is equal to 4 and m is equal to 3. So if we put the value of n, we get 6 plus 3 times 4, that is 6 plus 12, that is equal to 18. And if we put m here, we get 3 plus 5, 3, that is 3 plus 15, that is 18. This way, the fourth term of this sequence, first sequence, is equal to third term of the second sequence. If you notice, the same. Now we have arrived the first term. Okay. So we have calculated the first term is 18. Now whenever there are common terms in two equations, they will also occur at a particular common difference. When will they come? The next time, the next common term will be this concept you have to understand will come at the common difference of LCM of the common differences of both the series. So the next term will come at the common difference of LCM of the common differences of these two equations are 3 and 5, which is LCM of 3 and 5. So 18 plus 3 and 5 is what? 15. So the common difference for every next common term will be 15. So after every 15, if you add the terms, 18 plus 15 will be 33. So next 33 will be common in both these equations, and so on. So we can write this as, this will again make a series. So we can say that 18 plus n minus 1 into d, and d is the common difference. The common difference here is LCM of both the equations, which is 15, and this we have arrived at the series of the terms which are common. Now how many such series are possible? The maximum number for the first series is 330. The maximum the last term of the second series is 353. So the maximum common difference has to be less than 330, because if it is more than 330, it will not appear in the first term, and since they are common, they have to appear in both the terms. So maximum common term has to be less than 330. So we need to calculate how many n terms are there such that this form is less than 330. So this form should be less than 330. Remember, this is the series of common terms. We have calculated the first common term is 18, and every next term will come after adding 15 to the first term. Now this should be less than 330. We just calculated. We need to find the value of n for which the maximum value is less than 330. So plus 18 will go there. So this will be n minus 1 into 15. This should be less than or equal to 330 minus 18, 312. N minus 1 should be less than or equal to 312 divided by 15. Why there is less than and equal to? Equal to is because maybe 330 is common in both the equation, or the largest number has to be either 330 or less than 330. So 312 divided by 15, that is 20.8. So n minus 1 should be less than 20.8, or n should be less than 21.8. 21.8 is not a natural number or an integer. It's not an integer basically. So so the lowest number that is less than 21.8, which is an integer, is n is equal to 21. So there are 21 21 terms in this sequence, and this sequence is the series of common terms. So there are 21 common terms in both these equations. So the answer has to be 21, option E. All we did in this case is we first find out what is the first common term, and then we find out after how much intervals every term will be common. The common difference was 15, and then we calculate how many terms can be there if the maximum last term of that series is 330, and this way we put the values of 330 and find n should be the last n should be equal to 21. It cannot be more than that. So it means that there are 21 common terms. This is a very frequent type of question, and it has this specific pattern only with which we try to solve this question. Let's solve this question once more. Garvit, 6 plus 3n is equal to 3 plus 5m and not 5n. If you notice, we have assumed that this is equal to m and this is equal to n. So we have not assumed n is equal to we have not assumed n is in both the case. Check once. Yeah, perfect. E is the correct answer. Okay, we'll move on to the next question. Okay. Okay, I hope that you were able to identify a particular kind of series that we discussed today. This question follows the same series. It says that a rabbit covers a certain distance in such a way that he covers 1/5 of the distance covered on the previous day. So whatever he covered today, he will cover only 1/5 the next day. If he covers 12,000 meters on the first day, so on day one, he is covering 12,000 steps, 12,000 meters. So next day, day 2, he will cover only 1/5 of this. That is this. Third day, he will cover 1/5 of this. That is this into 1/5. And this will so on. If you notice, this is a geometric progression because every term is a multiplication of some particular constant, and that is called common ratio. And we discussed that whenever the common ratio is between less than 1 and greater than -1, then that particular sequence is an infinite series because it will keep on going, it will keep on reducing, and that will not end. So for that, the sum of the terms of an infinite series is first term divided by 1 minus r that we discussed. Okay, so in this question it is asked what is the maximum possible combined distance he can travel. Total combined distance, that is d1, d2, d3, d4 and so on. For that we discussed the same, that is sum of the infinite terms of this kind of series is a divided by 1 minus r. That is a is the first term is 12,000. divide by 1 minus. The common ratio here is 1 by 5 because every day he is covering 1/5 of the distance he covered previous day. So what the common ratio here is 1 by 5. This is equal to 12,000. 1 minus 1 by 5 is 4 by 5. Whenever there is a denominator in the denominator, it will go to the numerator. So 12,000 into 5 divided by 4. This will be 3 and the answer will be 15,000. So in total, the person will be covering 1/5 of the distance. In total, the rabbit will be covering 15,000 meter. My pet. So the answer has to be option D. Let's move on to the next question. Yeah. Okay, this was an easy question only. It says that the sum of the 4th term, 10th and 7th term of an AP is 27. So 4th term is A4, that is A plus 4 minus 1 into D, that is A plus 3. And we have 10th term, A10 is equal to A plus n minus 1, that is 10 minus 1 into D, that is A plus 9D. And we have 7th term, so A7 is equal to A plus 7 minus 1 into D, that is A plus 6D. We are given that the sum of all these terms is equal to 27. So if we add them up, we have A and A, 3A plus 3D, 9D, 12 plus 16, 6, 8, 18D. And this value 3A plus 18D is equal to 27. We know that all three numbers are divisible by 3. If we divide, we get A, this will be 6D is equal to 9. Okay, so from the relation we have got only this value. Now let's check what we are asked. We are asked what is the sum of the first 13 terms of the progression. Let's apply the formula of the sum of the terms, that is S13 is equal to, if we revise the formula is Sn is equal to n by 2 2a plus n minus 1 into d. So n is equal to 13, 2a plus n is equal to 13, 13 minus 1 is 12d. From this, we can take out 2 common. If we take 2 common from here, we have A, and if we take 2 common from here, this will be 60. 2 and 2 can cancel out, so this will be 30. A plus 6B we have already calculated, this is equal to 9. So the sum of 13 terms of this series is equal to 13 into 9, that is 117. So the answer has to be option number A. This was an easy question. Let's do next question. Let's move on to the next question. Okay. Okay, Garvit, you were saying option D. I'm not sure for which question. Let me know if you have any doubt regarding this. Okay, this was again towards on the easier side only. It says that the 14th term of an AP is 202. That is A14. We know that A14 is A plus 14 minus 1 into D. And this is equal to A plus 13D. And we are given that this is equal to 202. Okay. In the second part, it says that 19th term is equal to 277. So A19 is equal to A plus 19 minus 1, that is n minus 1 into D. This is equal to A plus 18D. And we are given that this value is equal to 217. Now what you have done is you have converted the terms into a linear equation, and I hope that you know that if you are given two linear equations with two variables, you can find out the value of the variables. From the first equation, let's say A plus 13D is equal to 202. So we can say that A is equal to 202 minus 13D. If we take this to the other side, similarly we have this. If we again take 18D to the other side, this will be 277 minus 18D. Now if you know that if LHS is equal, that is left hand side is equal, the right hand side also has to be equal. So we can say 202 minus 13D should be equal to 277 minus 18D. This is D. Let's take the like terms towards the same side. So 18D can come here. So 18D minus 13D. This should be equal to 277 minus 202. This will be 5D and this will be equal to 75. Or we can say D is equal to 15 if we divide this. Putting the value of D in any of the equation, let's put the value of D in first equation. So A plus 13 into 15. This is equal to 202. A plus this is equal to 45 and 195 is equal to 202. So A is equal to, if we take to the other side, this will be 7. So we have got the value of A is equal to 7 and D is equal to 15. We are asked that find the ratio of the series first term and the eighth term. First term, we already know that the first term of the series is 7. We can calculate the eighth term, that is A8. A8 is nothing but A plus 8 minus 1 into D, that is A plus 7D. We know that value of A is 7 plus 7 into D is 15. This is 105 and 112. Yeah, and we are asked the ratio. So first term ratio A divided by A8, that is 7 divided by 112. If you divide, this will be 1 and this will be 16. So the answer has to be option number C. Okay, for the mentorship, we have a helpline number. You can go to Cracku, you can contact us on the support number. Our team will connect with you and help you about all the relevant information, and whatever mentorship you are trying to seek will help you. Go to cracku.in, you'll get the support number. Contact us, call us, and the team will help you out. For the course, I think on the website we have completely released the playlist, and that too for free. You can watch the videos and cover the whole course. Again, the course is 100% free, guys. I would say go to the website. You'll get IIMB complete playlist, and then you can watch all the videos there. Also, we are releasing the same on our YouTube channel also, that too for the complete course. You can cover the syllabus there as well. Okay, yeah, we'll move on to the next question. Okay, so yeah, this is going to be an interesting question, kind of a little moderate question. Let's try. Okay. In the beginning only of this question, the question is already stating that it is an infinite geometric progression. It means the common ratio is between 1 and -1. Every term is equal to 4 times the sum of all the subsequent terms. Basically, every term, let's say in this equation, the first term is equal to 4 times all the terms other than the first term. Okay, if the fourth term of this progression is equal to 20, find the second term of this progression. Now it's an easy question only if you understand the concept, and if you do it in a simple way. Let's say the series is A1, A2, A3, A4, A5, A6 and so on. We are given that the fourth term is equal to 20, that is this is equal to 20, and we are told that every term is 4 times the subsequent terms. So A4 is 4 times all the terms which are after A4, that is from A5 till AN. We know that AN is A4 is equal to 20. This 4, if we divide it here, we get all the terms, sum of all the terms till AN. If we divide this, we get 5. So sum of all these terms, A5, A6 and so on, is equal to 5. And that is how A4 is 4 times of this. That is 5 into 4, 20. Now we can find out the value of A3 also. A3 is 4 times all the terms coming after A3. What is the sum of the terms which are coming after A3? That is A4, which is 20, plus all the terms coming after A4 is 5. So it has to be 5. So A3 will be equal to 4 into 25, which is equal to 100. Similarly, now we can find out A2. A2 is 4 times all the terms after coming A2. So what are the terms coming after A2? We know that A3 is equal to 100. So A3 is 100. We know that A4 is 20. And we also know that all the terms which are coming after A4 is 5. If we add this, we will get A2. 100 plus 20 plus 5, 125. And if we multiply, this is equal to 500. So the answer for this question has to be 500, which is option D. We were directly given the value for A4. We basically backtracked this. We find out what is the sum of the terms after A4, and then we backtrack to A3 and then A2, which was actually asked. Okay, now we'll move on to the next question. Yeah, this is the last question. Okay. It is based on harmonic progression. As we discussed in the beginning, that harmonic progression is nothing but if there is an AP, you just change the terms of an AP to its reciprocal, it will become an harmonic progression. Here we have said that the fourth term of a harmonic progression is 5. That is, if fourth term of a harmonic progression is 5, then the fourth term of a arithmetic progression will be what? A4. This will be equal to reciprocal of 5, that is 1 by 5. Basically, harmonic progression and arithmetic progression are, if you do the reciprocal and 1, you will get the other one. If harmonic progression's term is 5, the same term for the arithmetic progression will be 1 by 5. Similarly, 8th term of the harmonic progression is 20 by 3, and if you do the reciprocal, you will get 8th term of the AP. 8th term of the AP will be 3 by 20. Now we can write A4 as A plus 4 minus 1, that is 3D is equal to 1 by 5. Here we can write A plus 8 is A8 is A plus 7D, n minus 1, n is 8, so 8 minus 1 is 7. So A plus 7D is equal to 3 by 20. If we do the cross multiply, we have 5A plus 15D is equal to 1, and we have 20A plus 140D is equal to 3. Now we have these two equations, we can solve them. On the right hand side there is 3, here it is only 1. If I multiply this equation with 3, I will get 15A plus 45D is equal to 3. So now on the right hand side, both the terms are 3. It means on the left hand side, both the terms are equal. That is how they are coming 3. So we can write 15A plus 45D. This should be equal to 20A plus 140D. Taking the like terms to the same side, 45D minus 140D, this will be 20A minus 15A. This will be minus 95D is equal to 5A, or A by D is equal to minus 19 by 1. This will cancel out. So we have got this relation that A is equal to minus 19D if you cross multiply. We can put the value in any of the equation and get the value of 1 and find out the other one. Let's say we know that 5A plus 15D is equal to 1. Putting the value of A here, we have or let's say put it into the main equation only. It will be easier to solve. A plus 3D is equal to 1 by 5. A, let's put it minus 19D plus 3D is equal to 1 by 5. Or this will be minus 16D is equal to 1 by 5 and D is equal to minus 1 by 80. So we have got the value of D. If we put D here, we can get the value of A also. That is minus 9 into D is minus 1 by 80. Minus and minus will cancel out, so this is 19 by 80. This is equal to A. We have got the value of A, we have got the value of D. We can find out the terms now. We are asked, find out the 12th term of this harmonic progression. If we find out the 12th term of the arithmetic progression and do its reciprocal, it will become the 12th term of the same harmonic progression. So we need to find out the 12th term. That is A plus 11D. A is nothing but 19 by 20 plus 11 into D is minus 1 by 80. This is 19 by 80 minus 11 by 80, and this will be equal to 8 by 80, and this is equal to 1 by 10. So 12th term of the arithmetic progression is 1 by 10. If you do the reciprocal, it will become the 12th term of the harmonic progression, and the reciprocal of this is 10. So the answer of this question has to be option D. I hope that this was clear. Let's check if there is any doubt. What is HP? Okay. HP, okay, we'll move on to the same slide. Yeah, HP is nothing but if you have an AP, that is arithmetic progression, and if you do the reciprocal of each term, it will become an HP term. Let's say we have the arithmetic progression 5, we have 5, 10, 15, 20. This is an AP. If you do the reciprocal of each term, 1 by 5, 1 by 10, 1 by 15, 1 by 20, this is an AP. So if you know the HP, you just do the reciprocal of each term of the arithmetic progression, it will become HP. I hope this is clear. And yeah, I think it was the next slide. Yeah, this was the slide. You have 3, 6, 9, 12. This is an AP. If you do the reciprocal, it will become HP. I hope this is clear. Okay, we have already covered this. The answer is option D. Lastly, we have the 5 marks which are free for IIM B UG. All you need to do is go to Google and search Cracku IIM B UG mock test. The first result that you get will be of the same link to reach the test page. You can get the 5 tests there. All these tests are based on actual syllabus that is defined on the IIM B UG website. All these 5 tests are free. Go appear for the test, see what sections you are good at and what sections you need to work on. Also, if you want the complete playlist, you can go to Google and search Cracku IIM B UG course or online coaching. You will get the first link for the same, and you can get the complete playlist. And also, we are conducting all the live sessions for all the topics. Attend the live sessions. We are updating the schedule. You can see what session is coming up, what is the time. Do join the sessions. Also, we have the WhatsApp group. You can join the group, and so that you will not miss out on any important topic. Okay, Garvid, I'll share the feedback with the team. We can cover it in English also, but there is some audience who might not understand, so we try to cover it in English, but we'll think about it if we want our sessions to be in Hindi. Thanks. You can connect to you can go to Google, you can go to Cracku and contact the support number for the complete course that you are searching. All right guys, that's all.